Hey,
All right,
we're
guys.
live.
And we're live.
Very excited.
Where are we live on? It's going to be on
Internet.
Google Plus. But first, let me welcome everybody to our second Saturday discussion. This week is actually something that I feel like the absolute code newbie about because I did not start doing any kind of testing of my code until I joined this community maybe like 2 months ago. And
You're
my
welcome.
first tests were absolutely horrible. Like they were, I'm going to build this other program that just calls my program and does stuff. And although that sounds good, it's really not. um, but yeah, and one of the guys that's helped me out the most with testing is Jamal, who's going to be our speaker for the day. Um, I know he comes from a Ruby background as well as a Python background, so for you Ruby guys as well, I think that you will definitely get a good benefit out of this. Um, when he starts talking Ruby, my eyes might glaze over and I'll fall asleep, but who knows? So without further ado, I'm gonna pass it over to Jamal.
Hey, thanks,
One,
Jay.
one thing real quick I want to say. So the whole point of this is a talk, but it's also a discussion. So at
Yep.
any point, if you have questions, if you are unclear about anything, feel free to jump in and let's have an actual conversation about it. That's
Yes,
all.
thanks.
No problem. Go ahead.
Thanks a lot, Ron. And definitely, if you have a question, I want to keep this an open discussion. So please up and let me know. All right. So what I want to talk about today is, as you said, Jay, automated testing. And there's a lot that goes on in automated testing. There's a lot in the space, and it can get confusing, especially for someone who's looking to start out. And I'm going to try to simplify that and get a place where folks can start to explore and kind of take some of the mystery out of automated testing so that everyone can start playing with it and start using it in your code to make it better. So before I get started, did anyone have any questions or comments that they wanted to bring up? All right. Well, first of all, what is automated testing? And the answer to that is pretty easy. I mean, people talk about TDD and a lot of other things, but automated testing just in and of itself is code that you write to test your code. And, as programmers, we write a lot of code in our daily lives, and a lot of times we're writing code to make things easier for ourselves. Maybe we have a project we're working on to improve some particular process, or for someone else to improve their particular process. And we write the code to reduce complexity because there's a little work up front to write that code, but then once we've done it, you can just repeat it over and over and over again. And automated testing is just applying that concept to tests. I'm sure that each and every one of you tests your code in one way or another, whether that's automated or manually. But automated testing is just taking that and applying that same programmer's process to your tests. So why would you want to automate testing? Well, as I said, essentially, as we've all experienced, the reason we program is to make things easier on us. And by putting that little bit of time to write the code to get your tests going, you can then repeat it as many times as you want. And over the course of a long project, especially a big project, but even on smaller ones, that can save you time in the long run, because if you're manually testing, you're going in and you're setting up particular conditions to test certain things, and maybe at the beginning you're focusing on one area of your code, and then as you work through your code, you're focusing on another area, and you go through different areas of your code as you're building up your program. But you're not really focusing on each one of those areas. But if you have automated tests, you can just launch it. It'll run through all of your test cases that you've ever tested, and you can go from there. Obviously, because it's testing, it's going to help you find bugs, and some other benefits include being able to help other people know how your code is supposed to function. So again, on a shared project, when you're working with other folks, maybe I'm working on one portion of the code, someone else is working on another portion of the code. I might have a general idea of how your code works. You might have a general idea of how my code works, but when it comes to the actual functionality, maybe we've put some comments in there, but without something to make me feel comfortable that your code is working correctly or vice versa, we don't really know for sure. So it helps to having those automated tests in place can help you to know how code is supposed to be working. Does anyone have any questions about that? I know I kind of covered a lot there, and kind of knowing why we're doing this is a good thing. So if anyone has any questions, please go ahead.
You might want to explain TDD, just what that stands for.
Yep, I definitely will. I'm going to get there in a minute, but
Cool.
not quite yet. They are, I know a lot of times they're kind of lumped together, but TDD and automated testing aren't exactly the same thing. And
I got a question.
That's a good topic, and I'm definitely going to get there in a sec.
All right. Should automated tested be used even for single development projects for little time? You know, how small should you worry about it?
No, that's a very good question. It depends. I mean, automated testing, like anything else, it's a discipline, and it's something we do to reduce complexity. And so, you know, maybe if you're just writing a little shell script, no, I probably wouldn't write an automated test for that sort of thing. But if you think, or maybe you're just more comfortable doing it that way, there's nothing wrong with writing automated tests for any particular set of code. But I don't think there's anything rigid that says you must write automated tests for any particular code, if that makes sense.
For instance, suppose you're writing a small project and you don't have any plans on what you want to do with it, but it starts to grow. So at what point should you worry, you know, okay, from this point forward, it's very important that I use automated testing even to accept pull requests, you know, hooking up on the last week. You know, not even how small, but what's the minimum that, yes, from this point on, you should definitely use automated testing?
Yeah, I think for me, I can tell you what I do. If I'm just writing some kind of throwaway code to check the functionality of a particular module or library, or maybe I'm just doing a little one-off something that, you know, it's small, I know it's going to stay small, I'm not going to bother with writing automated tests. If I'm going to write something that I'm going to keep working on, push it up to GitHub, maybe call it something, give it a name, then I'm going to most likely write tests for it. Does that help? Kind of differentiate what I draw that line?
Yeah, it makes sense. So if you're thinking about GitHub, you should be thinking about automated testing. Yeah,
definitely. And you know, there's nothing that says you must do it one way or another. I just find that for me, it's a good practice if I'm going to be building out a module to try and incorporate testing, and to Kyle's point, TDD. But I want to kind of keep those distinct right now. Okay, so how does it work? How does a test work? How do we test our own code? And the basic idea behind that is simply to write code that's going to use the code that you're actually building. You're not your test code, but your module or your whatever it is you're making. It's going to call whatever methods or functions or however that functionality works. It's going to set up conditions, it's going to evaluate the results, and then it's going to assert that certain conditions exist. So break that down a little bit. Basically, you're going to be using your own code as if you were an outside entity, like maybe an end user, or maybe that would be if you're building like a module that other code would be using. You might use the API for your code. You might just load up the particular class or functions and just call them and evaluate the results. So that's the basic idea. You're kind of using your code not so much as something inside your code base, but something from the outside of your code base that's going to use the code base, just like you would be if you were using it from the screen when you're manually testing And then the second or the third part of asserting your results, that's simply using an assertion. An assertion is a way to ensure that something is true. And there's an assert function in most languages, I think. There's definitely unit testing libraries in a wide variety of languages. But basically, an assert, you test a case. If that case is true, it keeps going. If it isn't true, it's going to let you know in one way or another, either throwing an exception or something else to say, hey, this wasn't true when I got to this point in the code. And that's kind of the heart of testing, is evaluating the results of your code with assertions. So that's kind of the next chunk of building up automated tests. I don't want to get too far ahead of myself. Does anyone have any questions at this point? All right, we're almost to the point where we're going to be coding, so almost done with the setup here. Test-driven development now, as Kyle mentioned. TDD is a practice. It uses automated testing, and a lot of times it's associated with automated testing. It's a little bit different. It is where you write your code by writing your tests first, and then write code to make those tests pass, and then if you have any changes you need to make to the code that doesn't modify the functionality of your code, essentially a refactoring, you can do that at that point before you go and write another test to watch it fail. And I think a common mantra of the TDD community is red, green, refactor, where red stands for your failing test, green stands for your passing test, and refactoring is the kind of code cleanup that you're going to do through that cycle.
I have a question.
Yeah, sure, go ahead.
So I know TDD is something you use a lot for unit testing. Is that something you can do for like database testing too? Like with Factory Girl and stuff like that?
What's database testing?
Like
Yeah,
Factory Girl.
But you're not testing your database with Factory Girl.
Wow. Okay. What do you... I'm just now starting to read up Factory Girl, so I'm trying to learn what and how that would work with TDD.
Yeah, I mean, so all Factory Girl does is it makes it easier. So you know how when you're unit testing, you're testing your models, right? Which is like the closest, I guess, you can get to testing your actual database. So the database is just like the storage system. So you don't necessarily want to test the storage system. You want to test like the attributes and how the models work with each other. And so when you're doing your unit testing and you're testing your models, it gets really annoying to say like student.new and add all these attributes manually every single time. It's just an annoying thing to do. So Factory Girl just says, I can make a new student. And then Factory Girl knows what type of student it has and what type of attribute it has. So it allows you to make data way faster, so you don't have to manually make it. But you're not testing your database, you're using it to unit test faster.
Okay. All right.
Does that make sense?
Sorry to derail.
Oh, no problem. I was just like, what's database testing? I've never heard that before.
Yeah, and I think you mentioned a good point there with bringing up and tearing down a database for each test and whatnot. I should probably go into real quick what makes a good test. And good tests are repeatable, meaning that it's code. You can run it again. It's going to have the same results every time, as long as you don't change the code. So there's not going to be some kind of third state going on out there. And I think that databases can introduce a kind of third state where it might be too difficult for you to bring up and tear down a database each time. That's not always true, like if you're using SQLite or something. But say you had like an Oracle instance, you might not have access to bring up and put down tables or whatever. They should be reliable. So given the same code and the same infrastructure, you're going to get the same results each time, kind of going into the repeatable aspect. And they should be focused, so it should be zoomed in on a narrow point in your code rather than a wide point. And this is specifically for unit tests. There's other kinds of tests that will kind of do a wide spectrum testing. So yeah, I hope that made sense. Did some questions about kind of how to build a good test and what you might want to be focusing on when you do? Okay, cool. Well, if no one has any questions, let's go ahead and get started with some code. I kind of want to get get everyone involved here. So let me go ahead and start up my screen share, and we can start working on building a ROT13 encoder decoder. We're going to be using Python and the unit test libraries, which is built into Python. This is something that's going to be kind of similar to mini test in Ruby, or the old test unit in Ruby, which I don't know what happened to it, but I've been away from Ruby for a little while. I think mini test took its place. And it's based on the idea of what's called XUnit, which came from originally the Java community with Kent Beck's JUnit. And it's a style of writing tests that you can find in most any language. There's been a port to pretty much any language out there. I know that there's JUnit and unit for .NET and such other stuff. I included a wiki link for if you're using another framework or interested in finding what other frameworks are out there. It's in there. And I put the link a little earlier in this chat, but if anyone needs it, I can send it to you. All right, so let's get that screen share started. All right. So can everyone see my screen?
Yeah.
Cool. All right, so let's go ahead. I'm going to keep this simple here and not build up a proper project structure. Obviously, you would want to do that if you're making a real module. But in this case, I'm just going to create a encode.py and a test encode.py. Now, we're keeping these two files separate. Anyone have an idea what would go into each one of these files?
You'd put your actual production code in the encode and the test for that code in the test code.
Exactly, and that's something that's important, is you want to keep your tests away from your production code. If you were building this in a real module, I'd be putting these in different directories to keep them separated. All right, so let's bring up what we need here. We're going to need to import test unit, or I'm sorry, unit test. And we're going to want to import our module, which is called, we called it encode. Encoder? I don't remember. We'll call it encoder and go take a look. That was encode. Okay, so the way that this unit test framework works is that you will be creating classes that contain your tests, and those classes will inherit from the unit test test case. A little un-Pythonic because they pretty much a direct port of the JUnit library, so they actually have a little bit of a Java flavor to them, but they're very useful, so they're a good. I can excuse it. All right, so as we are thinking about a ROT13 encoder decoder, what is something that we might want to test with our final code to see if it is working? Let's go ahead and start there.
If you're encoding, maybe you want to test the SHA.
Test what? I'm sorry?
MD5. And usually, if you encode something, you want to see whatever it's encoded is properly encoded, right?
Okay.
So,
yeah.
And MD5 key for that's really good.
How low level do you want to get with this? Do you want to have a test where you do something like make sure the class even exists, or?
We could do that. I'm kind of leaving this open and going to let you guys kind of steer it, and hopefully we'll end up with something. Oh, let me talk real quick. I don't know if everyone's familiar with ROT13. Basically, it's an encoding algorithm, pretty basic, so it's used for a lot of examples. you would do a direct cipher. Basically, you move for any particular letter in the alphabet, you'll move it forward 13 characters, so that, for instance, A would become N, B would become O, C would become P. And then the nice thing about it is that you can run that encoded code back through the same encoder, and it decodes it because 13 characters takes it back to the beginning. So maybe let's go ahead and test that A encodes to N. Does that sound like a good place to start?
But while you're doing that, I think when Clay was asking how deep do we want to get into it when we're talking about testing,
Yeah.
I know this is obviously an example, but when we're really out there building our tests, like how granular do our tests need to be? How granular should they be? I mean, like he said, should we test that the class exists? Should we test that the variables are being inputted, that each attribute in a class is actually being inputted?
That's a very good question, and I think that, at least for me, finding that sweet spot is something that is taking some time. I wouldn't say I'm fully there. You definitely want to be testing your code in the conditions that you think it's going to be important and that you haven't already tested. Perhaps you can go overboard where you throw everything in the kitchen sink at it, but I think that's something that you start getting a feel for as you do it. And hopefully that's not avoiding that answer, but it's something that you go and try it out, and I think there's a point you get to when you're saying, this really isn't benefiting me, and then you can kind of pull back a little bit.
Okay. And one of the reasons why I asked that is the first time I ever heard of testing was at a public meetup for Python in San Diego, and he was talking about using unit tests to build your testing suite.
Mm-hmm.
And in his test, I mean, he tested maybe 500 lines of code about 2,000 times.
Wow.
And I'm just sitting there thinking to myself, like, why would you build that many tests? Like, what do you need to show for this? And
that's actually one good thing about test-driven development, because when you're writing the test first, it helps you to shape what your code is going to look like. So if you want your code to be able to respond to any particular set of bad data that's thrown at it, then you would write those tests to ensure that it's doing that. If you are maybe just playing fast and loose with a library and you don't particularly care because it's just for yourself, maybe you don't need to pass something in null or Unicode or something to every single function in there. You'll just say, okay, once it's gotten past this certain point, we're okay. But by writing those tests first, it's not always so much a question of should I test this as much as do I want my code to be able to handle these particular situations.
Okay, so it may not be necessarily you want to drill down to the bare bones of does A exist? Yes, A exists. You just defined it. But at the same time, you may think of ideas of, for instance, if you have a class that only needs one kind of variable, you need to make sure that you can catch all of the variables that might pop up.
Yeah.
All right. Cool.
Do you all know about like the sad path and the happy path? You guys heard of that before? No.
No.
So the sad path and the happy path. So the happy path is the desired outcome that you want your code to do, and the sad path are all the things that can possibly go wrong. And so one of the things that you test when you're writing your test is you definitely test the happy path, right? You make sure that if it's given all the variables and all the right situations, it's going to do what you want to do, which is like the bare minimum. And then if you think about the sad paths, there's like a million sad paths it could possibly take, right? And going through like all the things that can possibly go wrong can be incredibly laborious and time-consuming and frankly sad. So like one good rule is you always test a happy path or a couple happy paths. Yes, it can break all the things, but you test like maybe the 3 or 4 based on like the context of what it is you're building. You'll test maybe 3 or 4 of the most likely sad paths to take, right? So if you're testing for user input, then they have symbols that are bad, in which case your validation should pick that up. But like you test a couple a couple sad paths, and you definitely test your happy path. So that's kind of like that's one way to look at it in terms of how granular do you get and how much are you testing and how far can you take with it, and then you just find whatever's most comfortable to you.
Cool. Thank you. That's a good explanation.
Hey, Sarn, have you done any of the quizzes on Exorcism.io?
No, and I feel bad. Don't talk Katrina to that.
Okay. Well, I brought it up because they use, at least with Ruby and Python, I haven't looked at the other languages, they use unit tests as part of their way of telling whether or not you've completed the project. So what the project has a README that tells you what the actual project is, and then it has a file that is just unit tests with skips for everything but the first test, and then you go in and you skip each one. So if you want to see a good example of how a particular quiz might be solved using unit tests, go check out the Python or whatever language track on exorcism.io, and it's really good. Like, I'll post a link to just one of their tests real quick. I hate to interrupt, but I'm fixing to have to go. So I wanted to go ahead and get that out there. But if you want to see a bunch of unit testing used in different ways on different quizzes, exorcism.io is a good one and it has a whole bunch of languages.
Cool. Thank you.
Yeah, and
on that note, I gotta run.
Alrighty, take care.
Yeah. Bye.
Jay, on how many tests, you said they had 2,000 for just 500 lines of source code. Some of that may be because of the tests, they were able to refactor it down to 500 lines of source code, and they may have previously had more. And I also listened to an interview with the guy that is over the py.test project this week, and he said they had 20,000 tests for their code base. I don't know how big their code base is, but I know they had 20,000 tests for their code base, which is pretty impressive.
That is impressive.
So that brings up another thing. So if they were able to refactor their code because of their test to 500, they should have also refactored their tests. They should have gotten rid of those tests too, because that can be so the way that I do testing, I'll use my tests to know what my code base does. Especially if it's a code base I'm coming back 2 months later, I'll look at it and I'll go, wait, how does this work? What does this do? It's almost my documentation. And so if I remove functionality but the tests are still there, that's like a communication problem within the code base. So remove your tests if you remove your code.
Yep.
It almost seems counterintuitive, but refactoring my tests is often scarier than refactoring my code when I've got those tests.
Yeah.
I understand that.
All right, so let's go ahead and get back to this. I'll go ahead and screen share, but those are some good questions, so thank you.
And I put the link to that podcast. I actually listened to that podcast as well, Kyle, from Podcast and It.
Yeah.
Really good show. Almost as good as the CodeNewbie podcast. Almost.
Almost, yeah. I enjoy both. I'm behind on both because I've gotten so many podcasts in my podcatcher now, but I'm trying to catch up. All right, so let's go ahead and pretend that we've written this encode module and test that when we encode A, we end up with N. So let's say result equals encode. What do we want to call this particular function?
Hey Jamal, I'm not seeing the screen.
You're not seeing my screen. Uh-oh.
Thanks.
We all see it.
Yeah, I see it.
Yeah, I see it too.
Yeah, Shane, make sure you click on his name. You should be able to lock it in.
I got it, thanks.
Okay, awesome. Okay, so anyone have any ideas for a function name we might want here? We can always change it later.
Character encode.
Okay, sounds good. And we'll pass it A. And then we are going to assert that N is our result.
I have a basic Python question because I'm not a Python developer.
Mhm.
When do you use the the colons?
Colons they're kind of like in Ruby where you have your blocks and you might put your little curly braces. Instead, your white space is significant, so you do an indent and a semicolon and a colon.
Cool. Thank you.
Yep. All right, so we have a test here, and we're going to go ahead and try it. So to do that, unit test, Python M. M is going to run the module unit test, and then we tell it the name of our test that we want to run. Now, there's other libraries that will do, and I think actually a unit test will automatically find your tests, but in this case, I only have one file, so I'm just going to do it the easy way. And we have some output. So what does this mean? This is the output that we get from the unit test suite, which has run the test that we wrote. You can see it's very fast. It gives you a time, so thousandths of a second to run this particular test. Up here, you're going to see the results of each individual test, and there's basically going to be a string with one character for each result. It'll either be an E for an error, if there's some kind of error in the code, an F for a failure, meaning that your code executed, but your assertion failed, or it's going to be a dot. And the dot means that it passed, and that's the happy path. And then here it's going to give you some information about what exactly happened if there was a failure or an error, and it's going to print out one of these blocks for each of those. In this case, we have an error. It tells us which test we had an error in, and it says that the module object has no attribute, character, and code. Well, considering that we haven't written that yet, that makes perfect sense. So in TDD terms, we have a failing test. That's the red, and we can move on to the green, trying to make this test pass. So let's go ahead and do that. And call this encode. So character and code. Was the function, and that was what was failing. So we're going to put a pass there because that should make that error go away. So we'll go back and run it again. Okay, so we got a different error this time, which is good, meaning that we made this particular error go away. This time it says character and code takes 0 positional arguments, but 1 was given. All right, so anyone have an idea what that means?
You need to pass in something.
Exactly. So let's go ahead and give it an argument. Oops.
I have another Python question.
Yep.
Are there, so it says positional arguments. Does that mean there are different types of arguments? I think in
Yes.
Ruby there's like just arguments, but in Python are there?
I think there are generally considered 3 types of arguments. You have your positional arguments, which are just, this is a variable. You have, so he just put character, so that's one of your variables. You have your args, or your star args, which would be variables that have to be called by name. So if he made star args char, it would be char equals this. You'd have to give it a definition inside of your function. And then there are keyword arguments which are not defined in your function or your method, but they can be called. And that's kind of going pretty far into the woods there. So if it comes up, we can see it.
Yeah, basically that has to do with optional arguments and wildcarding and whatnot.
Yeah.
But yeah, they're essentially just arguments. but there's different ways of handling them, as Jay said. All right, so this should change our error, if not make our test pass. So let's go ahead and give it a shot. Okay. So what happened this time?
This time you got a failed. You didn't get an actual error.
Exactly. So our test isn't erroring anymore, but it is failing, meaning that our assertion is no longer, our assertion is running, but it's not returning the correct result in our code. So it's saying, hey, you failed. So any ideas of what we can do to make that pass? Down here at the bottom, it gives you some details. So what are we testing here? Our assertion tests that the result is going to be n.
Mm-hmm.
And right now, the result is none. So we want to make that n, right? So let's do that.
Yeah.
There you go.
One of the things that you want to try to keep in mind when you're writing in this automated test / TDD style is you want to just do the simplest thing that's going to work. Right here, if I'm kind of thinking ahead, I might be thinking in my head, okay, so for any given character that gets passed in, I'm going to want to rotate 13, and that's really just overly complex. So all we're testing for at this point is that this particular function returns n, so that's all we're going to do. We'll go ahead and run it, and we see exactly what we want to see. We see a dot up here, and we see an OK here, and we see that it did run the test. And it's passing. So we have our first passing test. Obviously, we don't have our functionality in place yet, but we do for the letter A in this particular function. So let's go add some more functionality.
I have a question.
Yeah.
In general, so we're going through like a very granular level, like making incrementally, like error, and now it's failing, and now it's passed. When you're writing tests, or after you have more experience, is it good practice to sort of like skip to a more meat and potatoes test, or is it always best to just sort of like incrementally go through and build your functions piece by piece?
I find that it is best for me to go through and make the test fail first. Sometimes I write a test that I think is going to fail, and it doesn't. And I'm not exactly sure why, but then digging into it, I find that my code isn't actually behaving the way that I think it does. So I might think that I've coded something that I haven't. So for me, it's a good idea to go in and get that, make it so that the test fails, check that the test fails, and go from there. Now, does that mean that I need to write, kind of going back to what we talked about earlier, do I need to check that every particular SAD path is accounted for or handled? It's kind of up to your personal taste as to how far you want to go down that path.
Mm-hmm.
Okay. Question on that: If you have the ability to test if the code passes, you should be able to also test if the code fails.
Mm-hmm.
Why wouldn't you, in that case, change your test to say, instead of if equals, but self-assert not equal? I mean, because at that point you're testing that you're getting the exact result that you're expecting, even if it is, hey, this test should fail. And I guess.
So, do you want to try a negative test?
Sure.
That we don't get a particular value? Sure. What would you like to test?
Just the same test. Since you set it to equal n, just set it to equal c, I guess.
Okay.
Or that it shouldn't equal c. Yeah, it does not equal c. And also, your function names, why are they just so long? Just asking. Why are they as long as they are?
I tend to like to be descriptive, so that I find that when I write really short function names, as I start building out my code, they end up being confusing because I've chosen a word that can have like 3 or 4 different meanings. And I'll go back later on and try to figure out what I was doing, and it gets confusing. So I try to be descriptive in my method, function names, variables, so that not overly so, but enough to make sure that when I come back to it, I know what I was doing. Good question.
It's also recommended in the Goat book, just so you don't have to have so many comments.
Yep.
But that function name is basically a comment, right? It doesn't matter.
Right.
Does it?
Self-describing.
Right. So, and I don't know about the other languages, but something that Python follows is what's called pep8, and it's basically just this is what you do to make your code clean. And one of the things that they tell you is if you can have defined or definitive function names and variables, it eliminates the need for comments in your code. Not saying that you don't need comments at all. You should always put comments. In fact, that's one of the things that they also tell you is that you should at least put some type of like .comment at the beginning of your classes and your method. But what this does is, so you don't have to say A is the variable that this got passed into, not equal to C the value that we're testing. You can just put in your function test that A does not equal C.
Yep.
My question is different, actually. Sorry. So, I mean, that function name, you're not going to use that anywhere else, right?
Which function name? The character in code or the
Both
test?
Both tests. Test that A equal whatever.
Oh, okay. And maybe that's, Jay, what you were asking about earlier, and I misunderstood. For the name of your tests, or for each one of your test methods, you want to start with the word test so that your test runner is going to pick it up. And then after that, just put a description in there of what exactly your test is going to be testing, so that when you see that it fails, you know what you were testing for in that particular case. And it helps to, I think, as Kyle said, document your tests.
And you can always refactor and change the name.
Yep.
If you need it to be a more general case.
Exactly. All right.
And I think you hit a good point on that too when you talked about when you have a name that's that specific. If you're going to go down into the weeds of my 2000 test, you may have some tests that are fairly similar, and I think being very specific with your names could also prevent you from having other issues arise down the road, whether it's accidentally calling the wrong functions, accidentally referencing a wrong variable. The more specific your information is, I think the better off your code will be as far as accidental errors that are a nightmare to find.
Yeah,
the scripted names actually help a lot in debugging.
Mm-hmm.
When you trace the names there, it makes out easy.
Definitely. Cool. Any other questions? All right, let's start the screen share back up. Okay. So, Jay, you said we want to make sure that we don't get, for instance, C. Now, I might not necessarily test this particular thing after I already know it's returning N, but maybe once we want to make sure that it's not giving, and maybe we can generalize something out of this later. So let's go ahead and write it and see what happens.
And that would be when you go to refactor your tests, like Saran and Kyle were mentioning before.
Exactly.
Build 1,000,000 tests so that you can only use 100 down the road.
Yeah, and sometimes you'll write a test like this, and it might pass initially, but you write another test that then breaks your functionality, and you've caught it with this test that you thought maybe you didn't need. So it can be good to put stuff. It's definitely good to put the negative testing in, and you never know exactly which test is going to catch you later on. Okay, so I ran this, and we now see that we ran 2 tests. It was it was blazingly fast. It took no time at all, and you'll notice that we got 2 dots here, meaning that they both passed. And if we wanted to see a summary, you can just go here and see OK. So that particular test passed without any modifications to our code, because it was already returning N, so it's not returning C. What else? What other way might this particular code behave?
Well, right now, I mean, we hard-coded the N, right?
Mhm.
So we should test a different letter, and then that'll force us to remove that hard-coded N and actually build it in functionality.
Definitely. Any particular letter that you want to test?
S!
S? All right.
It's like the Wheel of Fortune.
What does S encode to? F, it looks like.
Shouldn't we go already and start generalizing that already?
I'm sorry, what was the question?
Shouldn't we already start to generalize tests? You know,
Yeah.
instead of A, B, C, D, I'm gonna put all letters there.
Yeah, we can definitely do that. Let's get this test passing, and then we can look and see what we can generalize and what we can start doing to clean up this test code as well, if anything. So, all right, so we ran that test we wrote, and when we pass it S, it does not encode to F. It, in fact, encodes to N. So let's go take a look at our code and see what we can do to make that work. So going along the simplest path, what we might do is...
Are we going to use make trans?
Possibly.
We're not allowed to use, the CodeNewbie community is not allowed to use make trans. I'm sorry.
Oh, womp womp. Okay.
One way might... Oh, go
There's
ahead.
some inside baseball on that one.
Get our code to work is by doing this. Oops. And it, in fact, passes, but is that really what we want our code to do? We've got our test passing. Now we could look at our code and see how we might want this code to change. Anyone have any ideas how we might want this code to be modified to be a better, more flexible code?
You could take two lists and make a dictionary, like a key to pass letters back and forth, or make trans. If you really want to like go down that road, that might be easier.
Use ORD. It's a
Oh,
function that'll change it into a number, basically, that represents the, I think it's the ASCII character, but I may be wrong. And then you would add or subtract 13, whatever it is, and then use the opposite of that to turn it back into a character.
That is another way you could do it. So we're talking about a functionality change that's pretty big. I don't think we would that we would necessarily want to take this on in a refactoring. So let's try to write a test that's going to point us in the right direction. Maybe we want to test a new function that we would use to do that conversion. Maybe we want to... how might we steer our tests in the right direction here? Or steer our code in the right direction? How about handling more than one character at a time?
Okay.
In code, What's that going to be? That'll be G R G. And it yells at us and says there's no encode string function. So let's go make one.
While he's doing that, I just want to reach out to the guys that are watching right now in the YouTube chat. I'm glad that you're here. Also, if you go to the Google Plus page for this feed, there is a Q&A section. If you have a question, be sure to ask it, and we'll make sure that we get those answered for you.
Cool. Thanks, Jay. All right, so we made an encode string function. We run, and once again, we're missing our argument. We saw this last time. Wait, we have a argument there. We'll read that correctly. Missing one required positional argument. Second, oh, and assert equal. I wrote my test wrong. Aha. Okay. We weren't actually testing something. That we already wrote. So test encode. Here we go. Okay, so we don't get the correct value. Okay. So one way we might try and get that correct value would be to use our character encode and hook it up to our encode string, right? So for char in how would we do this? Any ideas?
Call character encode on each char.
Okay, so something like, what is going on with my keyboard? Let's see. Something like that, and then return is that what you had in mind? Something like that?
Yeah, looks good.
Cool. Let's give that a shot and see what happens. Okay, so we're now getting something other than none back. We're getting NNFN. So at this point, it pretty much forces us to go take a look at what we had before. So this is not the implementation we want. Which path do we want to take? We want to make a string of values and
But I don't know in Python, but in C you could just add to char, you know.
Let's test the waters and just do like the ORD adding, like Kyle said, where you take the ASCII number of each character and just add 13 to it.
okay.
And then loop.
So we now have, this gives us a good opportunity here, because if we're running our tests, we got a failure, but we're kind of diverging and going down a different path for a little while. So this allows us to use pretty nifty functionality here in unit test that allows you to ignore a test for a little while, but rather than commenting it out, it'll let you know that you're ignoring it. And it is unit operator to the test that you want to ignore. And the It's called skip. Skipping while we. Ooh, what happened there? To encode characters. What that's going to do is it's going to say, okay, well, you have 4 tests, but we skipped one of them, and right now we're at green. So let's go back here to our test and make a new test. Test that we convert character. Okay, so again, we're going to set up a condition in code.
I'm not sure if you answered this question earlier, but is it important that we put test at the beginning of each function?
That's a good question. Yes, it is. Especially when you get more and more tests, but even now, unit test is only going to, by default, find the methods that have test at the beginning. You can have other methods, so maybe you have a helper method or something that you wanted to set up, and you can put it in there. As long as you don't begin it with test, it will not run it as a test. But if you put test at the beginning, it will run that as a test.
Now, does that work with the underscore, or can you just put like test and then, if for some reason you feel like you must camel case it, will it recognize that as well?
You know, I haven't tried it. I don't think it does, but you can give it a shot. I'm not sure.
I'll let you know.
Okay. All right, so let's test and make sure that when we pass this to a character, we're going to self.assert result. We don't have a char to num. All right, so. And I think someone mentioned the colon, and when you put it in, this is a case of me not putting the colon in. It says invalid syntax. I didn't define it with a colon, so let's go fix that. Okay, so once again, we have 0 positional arguments. We want a character. And none type has nothing. It's digit, is digit. So it's not returning anything because we're using is digit to compare the return value. So we want to return a number. All right, so this should get us passing, but I think what we is digit isn't a, that's for strings.
That's a string method?
Yeah, it's a string method.
Oh, cool.
So I guess we can compare the type instead.
Or you can, is instance, maybe?
Is instance might work too, we can try that.
And pausing on that, I think you just jumped onto something very, very important. Like when you're testing, you will get some wacky results, and I think that's where you really need to, like, I see what you're doing here. You go back and you pull your unit testing framework out, and you can actually look at it and go, why did this fail? It looks right. I think that's probably the biggest drawback to testing that I believe a lot of beginners face, where they feel like they've built this test, the test looks right, the test looks great, and just minor syntax errors. And I noticed you're building also a lot of tests to test a single line of code. And I think with this exact example, that's why you need to do it. Because as you said before, you thought that it would work in that aspect. It didn't, but you need to know why. And your test should have passed if the syntax was correct, but you could maybe go in and it could have been the exact opposite, where you used is int, but that was actually a string. And your function could have been thrown off in that way, so that down the road, everything looks good, everything seems to be working, except for it doesn't. So because in my mind, I'm sitting there thinking, like, man, this guy is writing a lot of tests right now, and this is painful. Like, I would not want to sit here and write all these tests.
Team Gato.
Yeah, Team Typing Cat, exactly. I want to type as fast as possible and get the code done.
That's very true.
But this is a good example of, if I wouldn't have written all these tests out and I wouldn't have used this test-driven development, that's a very easy mistake to make in either your tests or in your actual code.
Very good point. And exactly why I do end up going through a lot of this seemingly painful stuff is because the alternative, at least for me in the past, has been, I get to a point where I'm sure that I've coded myself into a corner, it's not working, and I can't figure out why it isn't.
So I guess one of the big takeaways would be to say that, yes, you're writing a lot of tests, but writing a lot of tests is saving you a lot of debug time in the future.
I want to push back on this idea that it's painful. I don't think it's painful. And I'm going to tell you why. Because writing the code itself, yes, there's a lot of code that he wrote, but how much of it did he have to think really hard about?
True.
Like, to me, I measure pain by, like, how much of my brain energy am I sitting there thinking, wait, is it like, he really no offense, Jamal, but he really didn't start thinking until, like, the last test. All the other tests were like, oh, it wants an N, let's give it an N. It wants a B, let's give it a B. Like, it's like so little cognitive load until the part that matters. So to me, like, yes, you're writing for longer, you're writing more, but it's not painful because you're not like overexerting your brain when you're doing test-driven development. Whereas if you don't write that and then you get it wrong, you have to put in so much more work and effort into, like, backtracking and figuring out where, like, what exactly went wrong. And this way, he doesn't have to do that much.
Yeah, that's a very good point. And also, kind of dovetailing off of that, you'll find the design of your code changes. You might think up front, oh, I definitely need to use transcode. So that's the first thing you write. And then maybe when you're writing your test, you find out that you've written it without transcode and you like this implementation better. It helps to have what you need steer your code rather than your code kind of steering what you end up with.
I think that's a good example. Go ahead, Rigo.
Yeah, that's basically delayed gratification, right? Like a kid learning to stop waiting for the candy too early. But for us, it's more than 5 minutes.
The pain is in the gratification part. Okay.
Yeah.
And I think, like, a good example of that is the CodeNewbie Python group is working on a new project called Iron Coder, and I was one of the first subjects of this test, and I had my code built without building any tests for it, and, like, I'm just kind of making tests on the fly to make things work, and I got to a point where it was like, everything is working, everything looks great, and I wanted to add a new feature in, and it was like, there is absolutely no way that I can add this feature in the way that my code is built. And although, yes, I have a working product, I have to almost scrap like 80% of it just to make it work for this one little feature that if I would have just said, okay, let me build tests and let me test, every possible thing that I would want to do with this, I wouldn't be running into this problem now.
Yeah, you bring up another... I'm sorry, go ahead.
No, that's it. I'm just agreeing.
Yeah, you bring up another really good point where if you are going the TDD route and not just implementing automated testing, you'll find that when you write tests first, you'll make your code more modular so that you can use tests to kind of reach in behind the scenes, but then maybe you have another method that combines, you compose your code in a different way, I guess is what I'm trying to say, that makes it more flexible and helps to keep you from getting to a point where you want to go in and write your tests, but you just can't get to that one thing because it's behind 3 different layers of code and it's private and you can't even see it. So you're having to run a lot of other code to get to it. So yeah, that's a good point.
Well, right now, the code is writing is very, very useless, but we're going to see how that's going to turn out, right?
Let's hope so. That is
Because
that's the
A
theory.
return S, you know,
Yep.
it's not going to be applied for money much.
Yep. All right. So let's see if I'm right. Isint is going to give us what we want. Result is int is not true. Let's see what it's actually giving us. What?
I don't think so. You gotta wear car seat.
Let's do type on there and see. Maybe that's what I need to do. Oh, I needed to do type. Okay, so that was just me not being used to Python. So we need to get the type of the results and compare that to him. Okay, so it's returning a number. Do we want to make that number be its ASCII value, or do we want that to return some other number, maybe 1 or 0? How do we want to go about this?
You want it to be the ASCII number.
Okay. That's tests that. How would we test that?
You would, well, I guess the big thing is you would say whatever you're passing, you would just say ORed that value. So I guess you say result equals encode char number to num a, and then self-assert true a, or ORed a is equal to, or that result is equal to ORed a.
All right, let's try that.
Man, that was hard to say.
So you said ORed a.
Now, I see you're using self-assert equal. Can you just use a regular assert?
I believe you can, but I think that is not part of the unit test framework. I think that's an actual function within Python.
Okay.
So I'm not sure if the unit test framework was going to catch that. So when you're in this test case, you want to use the self-assert methods.
Okay. So you're saying basically it may pass, but it may also have unexpected results.
Exactly.
Okay.
All right, so let's run that. 97 is not equal to 0. So I think the easy way, without even knowing my ASCII, to get this to pass is so we now have a function that is converting it to a number, and if we're going to do ROP13, what do we want that? What do we want to do next? We want to try 13 to that? Anyone?
What was your question? Sorry.
So we've now converted this character. We now have a method or a function that's going to turn a ASCII character into a number. Do we want to go ahead and try adding 13 to it and make sure that we can do that?
Yeah, sounds good.
Okay. Test that. We add. So we have said that our chart and num method is, our function is going to return the actual result. So we should probably make a new one here, right? So result encode. I don't know what it is. what was it, 97 and 13 would be 110. Does that seem right?
Yeah.
Cool. All right, let's go for Sean. No char to encoded. All right, so I'm going to save us a little trouble here, and I'm going to stipulate we are, in fact, going to pass it something off the bat.
Did you mean to name it the same?
No, I did not. Thank you. Okay, so it's not returning 110. All right, so to get this to pass, we can definitely return 110, right? Okay. But point where we can say, okay, what we really want, we didn't want to return 110. We wanted to return Okay, so that was a good example of, well, we can make it pass this way, but what we really wanted to do, we want to go back and refactor this so that it is in fact hooked up to the method or the function that we want. And just to look at it again real quick, because I kind of skipped over that. So basically we're going to call this to convert it to a number and then add 13. Anything else we could maybe do here to clean up this code?
Yeah, hook up the first function.
Start squashing functions.
Okay.
Yeah.
So this is going to return an ASCII character. This returns a number. What are we going to need to do to transform that? I think we're looking for is it
Actually, we need num to char first, right?
yeah, we could do that. Do you want to do that? Okay. So we're going to go the other direction. Yeah, where's my, there it is.
I'm sorry, say again, what are we doing?
We're going to go the other direction from org test that can convert num to char. And in this case, we can.
So Jeremy asked a question here, and I'm just going to repeat it.
Okay. Yeah.
Is this type of testing, among other other testing scripts, the majority of what QA engineers are responsible for?
Are you asking, Jeremy, what developers would be creating these tests, or?
Yeah, because I mean, I've heard of like software. I mean, I guess it depends on your team size and whatnot, but if your company is big enough that you have like QA engineers, is this what they do, basically?
Yeah, I mean,
Go ahead.
So I was gonna say, I think it depends on your team. Like I've interviewed at companies where they don't do testing at all. In which case, I was like, I don't want to work for your company anymore. So yeah, I mean that's so disrespectful. But anyways, so I think that if you're a part of that team, like they have to have QA people doing nothing but testing. But my understanding of QA engineers is more manual testing. So like we talked about earlier, you can test some sad paths, you can test some bad scenarios, but you're not going to get them all. And the QA person is the one that's supposed to think of like every single possible thing that can possibly go wrong in bad weather and good weather on a Sunday at 4 a.m. Like every possible scenario. Like depending on the software you're using, they're the ones that have like all the different mobile devices and cell phones and try them out on every single router, like that level of testing. So usually QA is manual. It's not. I'm sure there's some automated parts to it, but they're responsible for the manual part as well, and it's way more intensive. But on a good developing team, the developer should also do some basic testing, like what Jamal is going through as well. So that's been my experience, my understanding.
So there's a podcast, actually, another Python podcast called Talk Python to Me, and they just had an episode with one of the developers at Netflix, and they use Python for a lot of their programs. But what they also do is create simulated, like, crashed environments. So they're actually going through and saying, as part of our test in production, we're going to intentionally take things down. That way we can kind of build these scenarios, and it's always just like random. It's always random. It's never like, you never know what's going to break. I think they call it like the code gorilla or the code monkey or something like that. It's weird, like, but it was such a great idea of, okay, we're going to build a system that we don't know what the error is going to be. We don't know what's going to happen, but we're certain through proper testing that no matter what happens, we'll be able to detect it, mitigate the issue, whether it's through getting an alert so you can execute some other bypass script or whatever you would have to do to make it work. And I think that's in a perfect world how you would see like QA engineers. They're the guys building this stuff out. But they kind of take it to the extreme. I think what Saran was mentioning and is fairly accurate it's extremely accurate, that it really just depends on the environment. It depends on the developers that are running the environment. I think that kind of comes into play. And that needs to be something that when you are actually out there looking for a developer job, that might be an actual good question of, what's your testing environment like? How are you building these tests? Do you do unit testing, or do you just cross your fingers, close your eyes, and push the big red button? Because that's what a lot of companies do.
That's my company, and it sucks.
I think that's a lot of companies, and yes, it does suck. It was sysadmin day yesterday, and I spent it fixing printers and correcting network issues because someone over the weekend had decided to just push a magic button.
Wow.
Nope.
I think real quick, this is a good point to point out that we're doing unit testing right now, and there are other types of testing, other types of automated testing. Not really going to go into them at the moment, just touching on real quick, like integration or functional testing. That'll be kind of composing multiple kind of review. Is this particular thing I'm trying to do maybe with a website? Say you have a Django or Rails website. Can I add items to this list and have them display on the screen? Something like that, where you're kind of stepping back and using multiple components of the system at the same time to ensure that something is going to happen. You can also have acceptance testing, which you might see a use case. So I'm a user and I want to go and add my favorite recipe to this website and have it display on screen and send it to my friend. And it's kind of taking one step further back. There's other automated testing. That one's pretty close to kind of integrated or functional, but it kind of takes a different slant. There's performance testing. How fast is this running? Is it fast enough? And there's lots of other kinds out there. So, I mean, this isn't the only kind of automated testing, but I think it's a good place to start, especially as developers and coders, to help with your coding process. All right. Any other questions before I get back into the code?
Nope.
Browser compatibility testing. I'm not sure. Maybe it's browser compatibility testing.
Yeah, you can actually. Well, I mean, we were talking about it earlier. Using Selenium to test browser functionality, you can actually import multiple drivers, and it could be a part of unit testing. It could be a part of, kind of going down the SAD path and having kind of that QA environment. I think it really just depends. There is really no. I guess when it comes to testing, the only bad answer is in production.
Or none
Don't
at
always
all.
test my code, but when I do it in production.
Oh yeah,
my
that.
gosh.
Not.
All right, so back to this. We're testing our conversion from a number to a character. All right, so let's go ahead and run that. We don't have num to char. So let's add that.
while Jamal is building this, we went through a similar challenge like this in one of the Python Thursday meetups, and I wish we would have done testing because we beat our heads against the wall for about an hour and a half trying to figure out why this did not work.
Mm-hmm.
That's where the trans code came from.
Yeah, the make trans.
That's where make trans is
Make
the
trans,
devil.
that's right. Not
To-
trans code.
To quote Waterboy, make trans is the devil.
Maybe another rule of thumb would be do test-driven development if you're going not solo, right?
I'm sorry?
I'm not sure.
I've actually
asking
used
it.
mine recently just by myself on a project that I wrote the main bit of the project 2 years ago, and I went back into it just a couple of days ago, and it horrified me. And so I wanted to refactor it and split it into modules, and I used unit testing and functional testing to make sure that I still had the same functionality and the same types of things happening in the code, but and ensure that while I was splitting it out.
Yeah, I definitely think that you can get away with saying that testing is something that it doesn't, whether you're by yourself or in a group, testing is something that can benefit you, especially doing automated unit tests like this.
Yeah. Agreed.
Yeah, and whether you know it or not, you're manual testing your code all the time. So automating it is just making it easier, per the coder's mantra.
Yeah, it may seem like a little more work up front, but you can see we're building up, we've got 8 tests now, and we were able to run it in 1,000th of a second, and I didn't have to think about any of the tests but the one I'm currently working on. So as that number of tests builds up, I think originally we were talking about, wow, we have 5,000 tests and thinking of that as a bad thing. But, it's also a good thing. I just tested 5,000 things in under a minute, and I know that they all pass. And speaking of passing, we're passing. So we're able to convert our number back to a character. So how might we implement this character in code in a better way?
Just chain them up.
Yep. All right, so let's give it a shot. So maybe we want to encoded equals char to return. Char. So we're calling this function that's going to turn it into a number and add 13, and then we're going to call this particular function that converts it back to a character. Let's see what happens.
No, that's not very Pythonic, is it?
Well, hold on, let's see what happens first.
Whoa! What happened there?
You did the absolute. I used the non-Pythonic. I hate that word. The non-Pythonic method. You need to add your was it if name equals main then main.
At the bottom?
At the bottom. I mean, that's what I would do. That way, you could still process all of the functions before you actually execute the code. Because right now you're trying to call a character encode. You're trying to call a function that hasn't been processed yet.
So you're saying that we're using these methods. I'm used to doing it in classes, but with functions, it reads the class in all at once, so you don't have to worry about this. So you're saying that this needs to go.
Or you can do it that way too. That works.
We get the same result.
Okay, well, if you look at the actual error, f equals x80, it's not equal to x.
Some character we did not intend to get. So what might be going on here?
Can you go back to your tests?
Yep, let's do that.
Okay.
I expected this to happen, but I didn't expect it to happen with F. So which test is actually failing?
Oh, well.
So,
okay, so this is the same problem that we ran into with the Python Thursday of it's not going to route back around if you test with... Are you testing with F or testing with S?
We're actually testing with S.
Oh, yeah.
That is what I was missing. So F... Yep, we got to the end of the alphabet, and we didn't go back to the beginning.
Mm-hmm.
So here, I think this is also a good example. Initially, we said, okay, so we have A, we want to get N. We might not have thought it was... We were actually writing this test to force us to change the way that we were converting those values, but now it actually caught something completely different, where it wasn't looping back around at the beginning of the alphabet. So it's something else to keep in mind, that maybe when you're writing those tests that you don't think are going to be necessary down the road, they can help catch stuff that you wouldn't have anticipated. Okay, so how might we fix this? I'm thinking it happens. I'm thinking the issue's in our. Let's go look at the. Issue is in this.
It's going to be in your chart encoded.
Yeah.
Because you're just adding 13, but eventually you're going to hit a character that doesn't translate back around, and you need to figure out where that is.
Right, because
so here, let's
ASCII,
go out into Python.
It keeps going.
Yeah. So the last character.
You're going to run into an error on your test, by the way. You left an empty function.
Yeah. I wanted to see what Z is, so that we can. So if we go, what is it? Ord is the one I'm looking for. String to ASCII. Ord. Yeah. Okay. So if we go Ord Z, what is this number? 122. So, quit. So if we go back into our tests here, we might say test that chart of encoded greater than end of might be a PEP 8 violation right there. It's 94 characters long, but I'll deal with it. Oops. All right, so let's go with one we know is going to fail that and choose Z. Search. What was it, less than? Search, there's no less than. So we'll just search true. Search true. Was it 122? Like so?
Yeah, I think better test in that case would be just ensure it will always return within a certain range.
Okay. Yeah, we can do a lower bound too.
You can even do like a for loop.
Yep.
And iterate that function again and again and again in assertions.
Yeah, I mean, you could do the entire alphabet if you wanted to, just to make sure it's in that range. But we have a failing test right now, so let's work on this one. So false is not true. So if it's 122, what might we do to our code to keep that 22 or something greater than 122.
You could do an if statement.
Okay. So encode greater than 122, do something. So what do we want to do if it's greater than 122?
Do
Subtract.
Okay, so let's take a stab at it and subtract 26, because that's how many characters there are in the alphabet. I don't know if that's the right way to do it, but let's give it a shot.
I think you got to add it to the ordinal of A.
Add it to the ordinal of A?
You get what I mean?
Subtract the ordinal of A?
Like take or
no, that's
so like if you end up with 130,
mm-hmm.
130 minus 122 is 8, and then you add that to the ordinal of A.
Okay.
And that'll get you to where you're supposed to be.
All right, let's try that. Okay, so what was the first step there?
Subtract the ordinal of Z.
Okay, so let's
take
of alpha Z. And begin with those. You wanted to get
you take the number you've got and subtract Z, or subtract the end of our list, and add it to the beginning of our list.
So encoded minus end of alpha, like that, and then return difference plus begin of alpha.
Right.
All right, let's give that a shot. I did not put a.
Those colons get you every time.
They sure do. Okay, so we have more passing tests. Something's wrong, but we're close because F and G are right next to each other.
So just +1 there.
Okay, yeah, we'll give that a shot. So F, G. We actually want -1, right? To get back to F. Well, we'll try it to +1. We'll see what happens. Okay. Yeah, that one.
I gotta get out of here.
All right.
I'm gonna check out your code later, though, Jamal. So
yeah.
if you could push it all up.
Definitely. I have a GitHub repo. I'll push it out there.
All right. See y'all later.
All right. Have a good one, Kyle.
See you, Kyle.
All right. So we'll try minus. That's passing. So we might be handling everything we need to handle now. So let's go back. We skipped a test, and we'll go code that and see what happens. Or unskip it.
I think you may run into a problem though.
Yeah, honestly, I'm not sure, but we'll see.
Because if you're supposed to get A, and you go to A and subtract 1.
There, that's what I want. Well, test is encoded correctly. So let's see. What do you think our case is that's going to fail?
Whatever value would return A. Because you're going to get to the start of alpha, you're going to subtract 1, and it's going to go back to Z.
So try the fox jump over the lazy something, right?
Okay, test. Full alphabet. And I think for this one, I'm going to take a lazy short and take advantage of the fact that ROT13 will encode and then decode by doing it twice. So test string equals the quick.
I would remove spaces.
Yeah, probably, because we'll need to handle that separately. Also, capital letters aren't going to be handled by this. Well, maybe it will. I'm not sure. Another thing we should test if we're going to continue with this. Fox jumps.
Brown fox jumps over the lazy dog.
Okay, so if we encode string, encoded equals encode. This should is a complete test, but this should be a smoke to see if we have something off in our math. Assert true, test. Oh, no, we want to assert equal. Something like that, right?
Decoded, right?
I'm sorry. Absolutely correct. I'm not sure what. Yeah, it passes. All right, let's give it a shot. Maybe we'll go in. This is where having maybe a functional test would be helpful to see where we would go next. I didn't want to get into functional testing today, just to get people started with unit tests. But functional testing can help steer you when you're not really sure where to write your next test. But instead of that today, we'll just fire it up and see what we got. So import code. Hello, CodeNewbies. We didn't want spaces because we're not sure if they're handled. Okay, and so there's our encoded. If we take a quick look at our reference here, H encoded to U, E encoded to R, L encoded to Y, O encoded to B. Looks good. And if we do that again, we want to. Okay, and so if we look at it, code thing. So code. We're back to hello CodeNewbies. So obviously there's still some flaws in this code, but since we're short on time and we got the basic encryption going, I'll open up to questions. I think places we could go forward with this is handle spaces, handle capital letters, but at least for lowercase alphabet, it's working. And I'll go ahead real quick. Establish. What happened?
Jeremy wants you to force push.
You guys are the worst.
The master?
Oh, geez.
Push force to master. So Ron said it was okay.
Right. Yeah, okay. And in case, so here's the GitHub repo. And I'll go ahead and put that link in there. And wow, did I really fill 2 hours?
Cool.
All right. Any questions? Any last-minute questions? I don't see any questions in the Hangout chat. So.
How was that for everyone? I think this is like our second one. How was it?
It was really good.
I thought it was great. I actually did learn a lot. I learned, the biggest thing of, hey, you could have solved this problem that you just ran into a long time ago if you would have followed these simple steps. And like you said, although yes, it is a little bit more code as far as the lines of code required, it is actually easier cognitively. It's like you're not thinking as hard, you're not doing as much. So I guess that although it seems like more work, it's less thought, which means you may actually get your code done faster.
Yeah. And if you apply that to a really big complex system where you're not going to be holding the entire thing in your head, then it's definitely nice.
And just as we saw at the very end, we had this issue of our original tests were still passing. I think that's one of the biggest fears that most people have when they start adding functionality is, oh crap, is this going to break something in the back? Am I really doing this the right way? And we even saw where, yes, it did, and there were ways that, we could even clean up the code, there were ways that we can make it look better, and that came out of the test. It didn't come out of, okay, well, I need to go clean this code up. It was, hey, these tests that are super simple are failing, and they're failing because that functionality isn't there anymore, or maybe it's been replaced by something else.
Yep. And I have a little confession to make. We did that little encoder decoder thing on the Python test, but I haven't implemented ROT 13 in Python before. I was going into this just hoping to rely on tests and make sure we could get through. Hopefully, we could get through it in time, and it worked out. So I'm pretty happy.
Live coding at its best, right there.
Yeah.
Like, no one's gonna know what will happen. All right, well, guys, I'm glad that you were able to make it in. Oh, I'm sorry. Go ahead.
Yeah, I had some expectation. I was trying to implement CI, Travis CI, with some Cloud9 application I'm trying to build. So I don't think I got out of here knowing how to do that.
Yeah, Jamal. Hi. You're talking about continuous integration. Well.
But still,
I feel like
I never saw a test-driven development being done before, and I had some ideas of how that would be, and it was really great to see this being done.
Awesome.
Thank you for that a lot.
I think we should totally do a continuous integration thing too.
Yeah.
Because it's one thing that I've used it because someone else set it up for me, and I just keep pushing. But if I had to set it up and explain it, I don't think I could do a very good job. So that would be. I feel like that in and of itself is a nice little thing that we could do.
Yeah,
that would be great.
Now, you mentioned that there are some other tools. I guess for the Python guys, can you ramble off some of those? I know py.test, that's kind of the big one.
Yeah. py.test is another framework that is, I like it a little better than unit test, but I wanted to use unit test for this because A, it's part of the standard library, or standard modules, I don't know how you say it correctly, and also because it's similar to the original XUnit framework, which you're going to find in any language. But yeah, there's also py.test. There's Nose, which is kind of an add-on to unit test, and it helps you go find your tests. It kind of sniffs out your tests. In Ruby, I haven't really been in the Ruby space much recently, but I know there's Minitest and RSpec, which does BDD. It's similar to TDD, and that's a whole different discussion. And I put a link in the doc to a whole bunch of other frameworks. Pretty much any language you can have a testing framework.
Great.
Perfect.
Cool.
Awesome. Well, thanks everyone for listening to me ramble on for 2 hours.
Thanks for rambling.
Yeah, it was really good. Thanks,
That's
Jamal.
wonderful.
And absolutely, if you have a topic that you would like to discuss on a Saturday discussion, be sure to join us in the CodeNewbie chat. We're there. There's usually a discussion every day, a few discussions every day, but you can let one of us know that, hey, you have a topic, and we can get you the information.
And we're happy to help and brainstorm too. If you think you kind of want to do something but you're not really sure, I like to talk a lot in case you didn't know. So reach out to me and we can like work out what the talk will be and stuff. And I'm happy to help.
Yeah, and for anyone who is interested in doing a talk but they're not quite sure they want to do it, this wasn't painful at all. Everyone was really helpful, and it was a great experience. So don't be afraid to step in front of the camera and lead one of these.
All right, everybody. Thank you all so much for joining.
Thank you.
Thank you.
See ya.